Hello. In this lecture, I will go over the basics of the three-dimensional coordinate system. Okay. Apologies for my handwriting. It's difficult to write on a writing tablet. Okay, so first, what is a three-dimensional coordinate system? The easiest way to think about it is that it's just an extension of a two-dimensional coordinate system, the Cartesian plane that you're used to, with the addition of a z-axis. Okay, so you just want to extend the two-dimensional coordinate system with the z-axis. Okay, so what would that look like if we go through and just go ahead and draw something here? So this is the typical way a three-dimensional coordinate system will be drawn. And in this case, the two-dimensional coordinate system, you can think about it like it's the floor. It's actually down here. So we think of this as the x axis, and this is the y-axis. And then the z-axis is coming up here, perpendicular to the plane. It's coming up off of the plane. And the angles in all these cases are 90 degrees. So 90 degrees between x and y, which of course is normal. And then if you took the floor and you just put a stick pointing straight up off the floor, you would get a 90-degree angle with anything that's on the floor. And since x and y are both on the floor, then you get 90 degrees there as well. Okay, so we think of this as the xy plane. So you can kind of go through and draw, a plane-looking object. So that's the xy plane, and then there's the z-axis coming off of it. All right. In terms of terminology, just like with an xy plane, we think of this point here as the origin. On top of that, what we're going to do is we're going to introduce some other planes other than just the xy plane. All right. So as you can imagine here, we've got the xy plane is defined by x and y. That means we could introduce planes that are defined by the other axes as well. So over here, we could have the xz plane. And then here we could kind of add the last one, the yz plane. The way that I like to think about it is that the origin here is kind of at the corner of the room, right? If you have a room that you're in and you can see the corner and you look at it, then xy here is the floor. And then you have one wall and the other wall, okay? So one wall is going to be our xz plane and the other wall is going to be our yz plane. Okay, so once we've got the basic idea down for what our three-dimensional coordinate system is, the next thing that we want to do is to go through and use it. So what we're going to do to use it is we're going to plot points. Okay, so again, let's start off with something that looks like our three-dimensional system. And let's say we wanted to go through and plot 1, 2, 3. Okay, so the way that you go through and plot points in 3 dimensions is very similar to the way that you plot points in 2 dimensions. So it's essentially kind of the natural extension of the method that you use in 2 dimensions. All right. So if we want to go through and plot 1, 2, 3, first the first coordinate is x, second y, third z. We'll say this is our x-axis, our y-axis, and our z-axis. And at least the way that I go through and plot points in 2 dimensions is I start off with the x, and I want to go the x distance, the distance here in the x coordinate in the x directions, right? So since we have 1, we want to go 1 in the x direction. So we can go through and maybe put some dashes on here to represent distances and try to be consistent as best you can. So we want to go 1 unit in the x direction. Once we've done that, we're here. Then the next thing we could do is to look at the y coordinate. Y is 2, so we want to go 2 units in the y direction. So this is the y direction since it represents the y-axis. This is 2 units, so you just want to take that and superimpose it here. So we want to go 1, 2. So we end up getting right about there. So that's 2. And then finally, the z coordinate is 3. So we want to go 3 units in the z direction. So this is the z direction. This is 3 units. So we want to just pick to basically take that and superimpose it here. So just want to go up right about there. Okay, so that point is point 1, 2, 3. Okay. Let's try a couple more like that. All right, we'll just do another coordinate axis. All right. And then we need another point. Let's try plotting -1 to -1. So the way that we handle negative numbers is that if this is the positive x direction, then the negative x direction will go the other way. So we don't draw it on here because otherwise your drawing would kind of look like a mess. But it's still there. So what we want to do is, so this is, again, we have x, y, and z. So we want to go 1 unit in the negative x direction. That would be right about there. Okay. And sometimes instead of going through and doing like a line like that, I'll do like a squiggle. Let's do a little squiggle there. And then next we have y is 2. So 1, 2. So we just do squiggle over to 2. 2 units. And then we want to go -1 in the z. So -1 would be what, like right about there. So we want to go squiggle down to about there. All right. And that would get us the point -1 to -1. And then maybe just try one more. So we could do, say, 3, -1, 0. All right, so if we did that, so first we want to go 3 units in the x direction. So that would be 1, 2, 3. So you just squiggle to there. And then once you get there, you want to go -1 in the y. So if this is 1 in that positive y, then -1 in the y would be maybe right about there. Just want to take that and kind of superimpose that onto here. That gets us to there. And then z is 0 this time. And so that's our point. And we would just stop there. If z had been positive, we would have gone up. And if z were negative, we would have gone down. Okay, so that is plotting points in 3 dimensions. The next thing that we're going to look at are some simple 3-dimensional objects. We'll look at more complicated 3-dimensional objects in later sections. But we're just going to get started with some simple ones. Okay, first, we're going to look at planes that are parallel to the coordinate planes. Oh, my apologies. The coordinate planes are the xy plane, the yz plane, and the xz plane. Those are considered to be the coordinate planes. Okay, so to introduce this idea, what I'm going to do is I'll start off by just giving us an equation of one of these objects, and then let's just see if we could figure out what the object looks like. So that's going to be a tool that I'll use now and then in the class, where I'll go through and rather than just kind of give everything to you, I'll just say, let's explore this and see what we can figure out. So let's say we were given the equation z equals 3, and we wanted to go through and figure out what that looked like. Okay, so first what we can do is we can go back to the previous experience that we've had in prior math classes. We've had to go through and graph things where we had limited information, where both x and y were not described, right? If you think back to going through and graphing in 2 dimensions, you might have been asked to graph x equals 1, or you might have been asked to graph y equals 5. Okay, and what did you do in those cases? If variables were missing, what did you do? The answer is you treated them as if they could be anything. Okay, so what this tells us is we want to go through and find points where the z coordinate is 2, or plot points maybe would be better. Right? So since x and y are missing, that means that x and y could be anything, and that it would still satisfy the equation, right? So if I went through and said 0, 0, 2, does this satisfy 0, 0, 3? Apologies. 0, 0, 3. Does this satisfy the equation z equals 3? Yes, it does, because there's no hint as far as what x and y are. All we care about is that z is 3. What about 1, 1, 3? Or 0, 1, 3? Or 1, 0, 3? All right, and you get the idea. You can go through and generate a bunch of different points here. As long as the z coordinate is 3, it's going to satisfy the equation. So now the question is, what type of object do we get if we go through and graph that? So let's go ahead and try plotting those points and see what we end up getting for our object. All right, so first 0, 0, 3, right? So this is saying x is 0, y is 0, z is 3. So starting here, we want to go 0 in the x, 0 in the y, and then to go up 3. 1, 2, 3. Okay, and then if we had 1, 1, 3, we would go 1 in the x, 1 in the y. That would get us to right about there. And then we would go up 3. We'd get that point. And then we could go 0 in the x, 1 in the y, and then up 3. And we would get this point here. And you could go 1 in the x, 0 in the y, and then up 3. All right. And maybe this is not quite enough to tell what's going on, or maybe it is. Depends. But what you could do is you could just keep going if you're not sure, right? So we could generate some more points. We could generate some points in the negative directions here, here, here. And then eventually you would kind of get the hint. All right, hey, this looks like a flat object, right? It's flat. It looks kind of like it's parallel to this flat object here, right? If you just went through and kind of sketched this in, right? It looks kind of like it's parallel to that, but it's located at z equals 3. And that is the right answer, right? So this is the plane that's located at z equals 3, all right? And it's the plane that's parallel to the xy plane, all right? So this is the first of our planes that are parallel to the xy plane, but we can just kind of generalize this. If you have z equals a, what this does is this generates the plane that is parallel to the xy plane at z equals a. All right, so it generates the plane parallel to the xy plane located at z equals a. Okay. All right, and similarly, you can go through and figure this out by experimenting, but we could go through and just guess as far as what the other potential planes are that would be parallel to coordinate planes, right? You can kind of see a pattern here if you look at this. You notice how we have z equals a and it's parallel to the xy plane, the other two letters. Okay, so you could go through and generalize this and say, all right, well, if we had x equals a, right, that would be the plane parallel to the YZ plane located at x equals a. And finally, if we had y equals a, that would be the plane parallel to the xz plane located at y equals a. Okay, and so that gives us a set of objects that are very simple, and they're just planes that are parallel to the coordinate planes. And it's kind of spelled out just by, once you know what to look for, it's just spelled out by the format. So if we had y equals 3, immediately we would know, hey, that's a plane that's going to be parallel to the xz plane, and it's located at y equals 3. Okay. Next, we're going to look at some simple cylinder objects. So cylinder objects are objects where you have extended one well, you're missing one variable and you're extending the object in that in the direction of the missing variable. Okay, so let's just kind of to warm up and start with something simple. Let's say we wanted to go through and graph x squared plus y squared equals 4. Okay, so the first thing that you'll notice is, well, hopefully you'll notice, we have an equation of a circle, right? And z is missing, right? Okay, so what that means is that we have a cylinder. We have a cylindrical object. That's the term that we use for it. And so to go through and draw this cylindrical object, we're going to draw this circle, and then we're just going to take that circle and we're going to extend it in the missing variable's direction. So let's see if we could do that. Okay, so first of all, when you go through and draw it, that might be the first spot where you're like, wait, where do I draw it? When you have this missing variable, what I usually do is I draw it on the plane of the two variables that are given. So I'm going to draw it on the xy plane. Technically, you don't have to do that. You could technically draw it for anywhere, for any z value. But I'm basically drawing it for the z value where z is 0. Okay, so I'm basically saying this is, for this to be true, right? For my picture to represent this object, it has to satisfy this equation Okay, and it doesn't matter what the z value is. So I'm just going to pick a z value. So I'm going to pick the z value where z is 0. And that's typically what I'll do on all the cylindrical objects. And I recommend you do that too. That's going to be the easiest way to do it. Okay, so we want to draw the circle on the XY plane. Okay, so here's our XY plane. And the easiest way to draw a circle is just to go through and use some intercepts. So what you can do is you can go through and you can say, all right, well, 2 is going to be an intercept for X, and 2 is going to be an intercept for Y, and -2 is an intercept, and -2 for X is an intercept. And then we can go through and draw. And look at that, we get a circle. And I know it doesn't look like a circle, but that's because the XY plane, we're looking at it from an angle. All right, so it's going to look a little skewed because of that. All right, so to go through and now that's not the whole object. That's just the circle, x squared plus y squared equals 4. The last piece to go through and finish the cylinder is you want to take the object and extend it in the missing variable's direction. So because this object is just where z is 0, since z is not mentioned, z could be anything. Z could be 1, or it could be 2, or it could be 5. So we're just going to go through and to do the extension, I'm going to draw vertical lines extending through these points. And then I'm going to draw another circle above the one that is there. And you want to just do your best to try and sketch something that looks kind of similar. And you get your cylinder. All right, and so that's how we go through and graph simple cylinder objects. So we have some simple cylinder objects in this section, as well as our planes. Let's go through and try a couple more simple cylinder objects. Over here, let's do z equals y squared. Okay, so the first thing you'll notice, right, is that this is the equation of a parabola. And x is missing. Okay, so we want to go through and draw our parabola and then extend it in the x direction. Now, as far as drawing the parabola, it might take you a little bit of getting used to go through and draw objects that are in different variables than you're accustomed to, than x and y. What I recommend that you do for that is to just plot points. That's the way that you first learned how to go through and figure out what objects look like. And it works very well here. So let's say we had z equals y squared. Since y here is the independent variable, you can just plug in some y values and generate some z values. And again, we're ignoring x here. We're going to draw this on the yz plane. Okay, so you say, what about x? But just ignore it. We're going to extend our object in the x direction at the end. So just pick some y values to plug in and then find the corresponding z values. So if we plugged in 0 for y, we would get 0 for z. If we plugged in 1 for y, we would get 1 for z. And if we plugged in 2, we would get 4. And then at this point, you probably know what it looks like, right? Okay, and so here we've got our parabola, z equals y squared. And then the last thing that you want to do is you just want to take this and extend it in the x direction. Okay, so the way that I did that last time is I drew vertical lines and then drew the circle. This time I'm going to do the opposite, not because I'm trying to confuse you, but it's easier to draw the parabola again and then draw the lines. So just take that parabola that you drew, pick some x value over here, and then just draw another parabola out here. Okay, and then just do your best to try and draw a shape that's kind of similar. And it might not be easy, especially hard with a writing tablet. That's actually not too bad. And so you can see I've just taken the parabola z equals y squared, and I've extended it in the x direction. And then the last thing you can do is to go through and draw in the lines. So you can also do it this way, where you do the lines last. It doesn't really matter which way, whichever way you prefer. Okay. And then one more. So the last one we're going to go through and do is y equals x. All right, so the y equals x is going to end up being a plane. In a lot of cases, the planes are the hardest to draw. It's easier to draw a circular cylinder or a parabolic cylinder, but drawing a plane that extends in the third direction can be kind of a pain in the neck. All right, so again, we have y equals x, and if you were going to kind of describe what that is, well, it's a line, right? It's a line, and z is missing. All right, so first go through and draw the line y equals x. Okay, so how would you do that? Maybe that's not the easiest thing to do. Well, keep in mind, we're just drawing it on the xy plane here. That's the bottom plane here at the located at the bottom. And the way that we're going to do that, again, the easiest thing to do is if you're not sure as to plot points, right? So if you plug in 0 for x, you get 0 for y. If you plug in 1 for x, we end up getting 1 for y. If you plug in 2, you get 2. All right, and so by now you can kind of see it, right? So it's going to be a line that extends from the origin out toward us. Like that. Okay, and then what we want to do then to go through and do the cylinder part is we want to take that line and we want to extend it in the z direction. Okay, so we're going to extend it in the z direction. So to do that, just pick a spot up here, and then we're just going to draw that line again, and that's going to be the extension, and then we'll kind of connect it with an additional line. All right, so you just want to take this line here and just draw it again. All right, and then finally the connecting line would be is the line that shows the extension that we're doing. So we're extending it in the z direction. So we want to draw a line that goes up this way. And you can see the end result is that's a plane, right? So I guess I haven't defined a plane. I'm not sure whether that's kind of in your lexicon, but a plane is just like a piece of paper, right? It's a flat two-dimensional object. Okay, so these can be difficult to draw. This one this one wasn't that bad, but it's because I intentionally chose it to not be that bad. Sometimes the planes can be kind of a pain in the neck to draw. Okay, the next thing that we're going to look at is graphing intersections of objects. Hold on. All right, so there's a bunch of different ways to describe this next part. So you can think of it as an intersection of objects. You can think of it as an object with a restriction. You can think of it as an object at a location. These are all correct, and there may be more on top of that. So what am I talking about? Let me give you an example, right? So the idea is if we have x squared plus y squared equals 4, so we take our previous object, and then we add a z equals 1. Okay, so one way to think about this is that you've got a cylinder, right? X squared plus y squared equals 4. We determined earlier this was a cylinder. And we've got a plane, and it's what would you get if you had those two together and you had the two intersect, like if they hit each other, what would happen? Okay, that's one way to think about it. Now, maybe it's not the easiest way to think about it, but it is an appropriate way to do it. So let me just kind of try and sketch for you like what that would look like or how you could go through and kind of explore that. You know, if you thought about it that way. So if you did, what you do is you'd go through and you could kind of draw the cylinder first here. So we'd have, you know, like we earlier did, 1, 2, 1, 2, 1, 2. So we're going to go through and get our cylinder, or sorry, our circle, and then we can go through and extend it, right? So we can go all right, so we've got our cylinder, and then the idea is that, you know, this is not some given value. It's just kind of a, you know, hypothetical value that's well above the XY plane here at the bottom. Now, if we went through and said, all right, so now we've got our cylinder, that's this guy. We could go through and say, all right, well, we got a plane here that's intersecting it, that's cutting through it. So if you went through and went back earlier to how, you know, to drawing planes, right? So we want to draw the plane here that's parallel to the coordinate plane at z equals 1. If you pick some spot here and say, let's say that's z equals 1, and you draw a plane there, right? So a plane, you know, and it's the plane that's parallel to the xy plane. So you could just go through and kind of just throw some lines on here. The idea is you're chopping through the cylinder, you know, what would you end up getting, right? So you'd end up getting, let's use a different color so that we can kind of differentiate. All right, so the intersection of the cylinder and the plane would be that red thing, right? So if someone asked you to go through and graph x squared plus y squared equals 4 and z equals 1, that's going to end up being a circle. The intersection of a cylinder and a plane is a circle. And that's how you could figure it out, would be to kind of go through and draw yourself a picture where you've got the cylinder and the plane and the whole thing together. Now, that's, again, probably not the easiest way to go through and do it. If you're just trying to do it the easiest way is probably to think about mixing, you know, going through and graphing an object at a location is probably this third definition, right? So the idea is that if you did it that way, again, we kind of just start over. You've got your coordinate axis. Okay, and what you could do is you could say, all right, so I want to graph this. This is, I know this is a circle, and I want to graph it at z equals 1. And so you could just go, okay, I'm going to go to z equals 1, and then I'm going to go through and I'm going to graph this circle. All right, so to graph this circle, you know, what do? Well, you know that it's the circle of radius 2. So you go 2 in each of the coordinate directions. So we want to go 2 in the x direction, 2 in the y direction, 2 in the negative y, 2 in the negative x, and then we end up getting our object, our circle. And there's your answer. Okay, so that's probably a little easier way to do it, but I think this is, the intersection idea is a little bit neater. It's, you know, maybe more easy to wrap your head around. The notion of having a circle at a location. You know, it's like, well, what about the missing variable here? Well, it's here. I mean, so that's just something you have to kind of put the pieces together to really understand. But it's a way to do it. All right, so let's do another example like that, because these are problems that you need to be able to do. All right, so the next one, let's do y equals x and z equals 4. Okay, so we could go through, draw the coordinate axis. All right, so then we could go up 1, up 2, up 3, up 4. So here's our location. Now what we want to do is we want to draw the line y equals x. Now you'll recall earlier, and what you can do here, if you want it to help you out, you can just maybe sketch it down here on the xy plane. So you can call it earlier, we drew, this was the line y equals x. So you just want to take this shape and now draw it at z equals 4. Right? And there's your answer. Okay, so it's the line y equals x located at z equals 4. And then one more. Oops. So we could go through and do z equals y squared and x equals -2. Okay, so to do that, you want to go 1, 2 to x equals -2. And then there we want to draw the shape for z equals y squared. So we can recall earlier that was the parabola that was located, here on the yz plane. So you just want to take that parabola and draw it here, right? So to go through and draw it, this would be the vertex, and then we could go over 1, up 1, left 1, up 1. And if we're feeling really lazy, we could just throw a curve through the 3 points. And there you go. So those are our simple objects. And I think I'm going to stop the video here and create a second video because I'm afraid this one's getting to be too long. Okay, so look for the second video on this topic, part 2,